Good morning, my dear students. My name is Dr. KCH Apparao, working as an associate professor in mechanical engineering department. Okay. Today, I would like to explain about the definition terminology of mainly boiling related terminologies or boiling and condensation. Next, to radiation also will we will cover. Okay. So first of all, we'll see definition terminology which are related to boiling and condensation. Okay. So what is boiling? Uh, in convection, we will see only heat transfer from solid to liquid or liquid to liquid or fluid to fluid. But in boiling and condensation, we will see the phase change with heat transfer. Heat transfer with phase change. So phase change is associated with the latent heat. Okay. So what type of in boiling the vapor water is converted into vapor. Water is converted into vapor. So heat transfer plus conversion of liquid into vapor. So that is called boiling. So what is condensation? Condensation means just reverse. Conversion of vapor into liquid. So phase change, the change of phase from vapor to liquid is known as condensation. A pure substance condenses at temperature equal to boiling point. You know this one. Okay. What are the applications of the boiling and condensations? You know this one. The boiling and condensation process finds wide applications as mentioned below. In power plants, power generating plants, thermal power plants, and nuclear power plants. So huge application of boiling and condensation are there because of mm, just boilers are there. Okay, refrigerating system, air conditioning system. Next one is the process of heating and cooling system. Okay, condensation, conditioning systems. So many applications are there because it is very important topic. Boiling and condensation in every area it should be needed. Okay. So what is meant by nucleate pool boiling? So you know that different types of the boilings. What is nucleate pool boiling? Okay, nucleate boiling is a type of boiling that that takes place when the surface temperature is hotter than the saturated fluid temperature. So boiling occurs when the temperature of the solid Ts is greater than the T saturation of the fluid. So it means so that is excess temperature that is represented by excess temperature delta T is equal to Ts minus T saturation. Okay. If there is no excess temperature, there is no any phase change. Phase change occurs when the surface temperature is greater than the saturation temperature of any fluid. Okay. So, but where the heat flux here in the case of nuclear fuel flowing, so heat flux is below the critical heat flux. So the heat flux, the rate of heat transfer is below the critical heat flux. So you know this one critical heat flux also. The critical heat flux is the peak on the curve between the nucleate boiling and the transition boiling. You know this one. What is meant by pool boiling? First of all, we'll see pool boiling. Pool boiling is the process in which heating surface is submerged in a large body of stagnant liquid. It means it occurs by buoyancy effect. Okay, so natural convection type. The relative motion of vapor produced and the surrounding liquid near to heating surface is due to primary to the buoyancy effect. So it occurs just like due to the buoyancy effect, uh, the densed particles moves into upward direction. So automatically that water is converted to vapor. These are the modes. So what are the modes of condensation? There are three types of modes of condensation. One is the film phase condensation, drop phase condensation, direct contact condensation. So these are the, we'll see one by one. What is meant by film phase condensation? The liquid condensate wets the solid surface, spreads out and forms a continuous film over the entire surface. So film phase condensation means, so suppose this is the container. If you heat this one on this body, so if you increase the heat transfer rate, it means so the delta T is greater than the 30 degrees nearly. It means Ts minus T saturation is greater than the 30 degrees. Automatically, rapid bubbles will be produced. Those bubbles combine with each other and forms a just like film pockets. These film pockets are formed on the surfaces. Okay, so this type of condensation. Sorry, this is the film wise boiling. Sorry for this one. So in condensation, so similar to this one also. This one is just like solid surface. Okay, so in this condensation, the water is formed on this surface, like it blankets the surface. That means so that film of water is covers the total surfaces like this one, total surface. So that is called film phase condensation. Drop phase condensation, just like here, this is the film phase condensation. This one is the drop phase condensation. Film phase condensation, we say the condensate wets the surface and forms a liquid film. So slides down under the influence of gravity. So because of gravity, this water slides down. The surface is blanket. The surface is blanket by the liquid film. Okay. So which serves as resistance to heat transfer. You know this because this film has the low conductivity because of that is a fluid. Thermal conductivity of the fluid is very less compared to solid. Okay. So this is called film phase condensation. So next one is the drop phase condensation. So the drop phase condensation, the condensed vapor form. So the condensed vapor form droplets on the surface. So here some drops are formed on the surfaces. The droplets slide down when they reach certain size. So if the size of the drops are increased, the drops in downward. So the droplets slide down when they reach certain size and clearing the surface and exposing it to vapor. Okay. So no liquid film to resist the heat transfer. Okay. As a result, heat transfer rates that are more than 10 times larger than the those associated with the film condensation can be achieved. So this is the film phase condensation. That is, this one is the drop phase condensation. Okay. So we already explained this one. Direct contact condensation means it occurs when vapor is brought into contact with the cold liquid. Okay. So as in jet condensers, the cooling water is sprayed on the exhaust steam, and there is a direct contact between the exhaust steam and the cooling water. Okay. That is the condensation, direct condensation. Hmm. Next we'll see boiling. So what is nucleate boiling? Nucleate boiling uh, is the type of boiling that takes place when the surface temperature is hotter than the saturation temperature. Okay. So it means so Ts is greater than the T saturation. So delta T is greater than Te is greater than, so it has some values are 5 degrees, 5 to 10 something. We'll see. nucleate boiling. Okay. So when the surface temperature is hotter than the saturation fluid temperature by certain amount, some amount, so not 0 or 5, 6 or 10. Okay. So when where the heat flux is below the critical heat flux, the heat flux is below the critical heat flux, that is nucleate boiling. In the nucleate boiling, just like due to the effect of buoyancy, the denser particles moves into upward direction, light denser particles, heated particles moves in upward direction. Automatically, this water is converted to vapor like this one. That is a nucleate boiling. Next, emissivity. So the purpose of the boiling, this one, the conversion of just like water or liquid into vapor. That vapor used as a steam energy to run the turbines and to produce the electrical energies. This one. Emissivity. This one. Emissivity, which is related to radiation. So these are the terminology which are related to um, radiation. Radiation. Emissivity. The emissivity is defined as the rays of energy radiated from a material surface to the radiated from the black body. So, emissivity of the gray body by emissivity of the black body, because black body emissivity is very high. That is epsilon b is equal to 1. Remaining emissivities of the bodies or remaining bodies emissivities are varies from 0 to 1. Okay. Highest emissivity value, that is 1 for black bodies. Okay. So the ratio of this one, emissivity of any body to emissivity of the black body, is called emissivity. Okay. So this is the emissivity. Okay. Energy emitted from a surface. Sorry. Yeah. EB by EG by EB, black body. Energy emitted by gray body or any body to energy emitted by black body, that is called emissivity. So energy emitted from a surface to energy emitted by black surface. Okay. So we know that this energy EB, the value, it is we can measure this one, we can find this one by the help of the Stephen Boltzmann law. So Stephen Boltzmann law used to studying the overall emissive energy, EB. EB is equal to sigma A into T to the power of 4, according to Stephen Boltzmann law. This one. Okay. So next, what is the units of emissivity? Emissivity is a unitless. You know that. Next, what is the meant by reflectivity? Reflectivity. Suppose this is the impinges on ray. Some portion will be reflected, some portion will be absorbed, some portion will be transmitted. Okay. This one. Three types of reflection means the ability of surface to reflect radiation. So equal to the reflectance of a layer of material sufficiently thick for the reflectance not to depend upon the thickness. Okay, it is represented by rho. So the ability of a surface to reflect the radiation, that is reflectivity. Reflectivity is represented by rho here. Absorptivity, some portion will be absorbed, some portion will be reflected, some portion will be absorbed, some portion will be transmitted. Okay, this absorbing. Absorbivity is defined as the ratio between the radiation absorbed and incident radiation. This is the incident radiation, radiation absorbed. So it is represented by alpha. So next, what is Stephen Boltzmann law? Stephen Boltzmann is uh, the emissive power of the black body is EB is proportional to the, so fourth power of absolute temperature. Fourth power of absolute. It means EB is directly proportional to T to the power of 4. Okay. EB MC power is equal to sigma into, if you consider area, T to the power of 4. That is the Stephen Boltzmann law. Okay. Absolute temperature. Here we can see this is the incident energy. Some portion will be reflected, some portion will be absorbed, some portion will be transmitted. So total is equal to 1. Okay. So incident energy on a surface per unit area per unit time, that is called irradiation. That is the irradiation. So this is the formulas. Absorptivity, the alpha represented by alpha is absorbed radiant by incident radiation. So reflectivity, reflected radiation by incident radiation. Transmissivity, transmitted radiant by incident radiation. Total is equal to 1. Okay. What is Wien's displacement law? The Wien's law gives the relationship between the temperature and wavelength corresponding to maximum spectral emissive power. For finding the maximum spectral emissive power at a particular wavelength, we'll use this Wien's law. So this is the formula for the Wien's law. It means at a particular wavelength, the emissive power will be reached maximum. Okay, we'll see. So maximum wavelength is the Wien's displacement constant by temperature. So delta max is equal to 2897 by temperature. Okay, absolute temperature. Okay. Next to black body spectral emissive power. Spectral emissive power EB lambda is the amount of radiation energy emitted by black body at absolute temperature. Okay. So per unit surface area at particular wavelength. So that is called spectral emissive power. Overall emissive power, that is that can be derived from the Stephen Boltzmann law. This one is the spectral emissive power. Spectral emissive power by the help of Wien's law. Okay, so this one is the Kirchhoff laws. So this one also very important. This law states the ratio of total emissive power to absorptivity. So is constant for all the surfaces which are in the thermal equilibrium with the surroundings. These are the just different terminologies which are related to radiation. And the radiation, what is, so different laws are there. Stephen Boltzmann law and Wien's law, and so these are the laws. We already saw this one. So these are the just like definition and terminologies which are related to boiling and condensation and the radiation. In next class we'll see few more definition terminologies which are related to radiation. Thank you for listening this class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.